And we're back. So, hairpin, 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 other side. Going to the incandescent bulb here, through this primary of this other transformer, CFO on the secondary, through another incandescent bulb in series. So we have, in series, we have a bulb, a transformer primary, and another bulb. These are 25 watt bulbs. And they're in series coming off of the second and the other hairpin here off of the high voltage side of the MOT. So we've already seen how we can get plenty of light from this system with the CFL bulb in part 1, or right across the high voltage here. Lights it extremely bright. Uses fractions of a watt. Over a period of 3 to 4 hours, we saw 2 to 3 watts consumption. However, now that we turn it on, you would expect that having a capacitor in series and then 2 more capacitors in series here off the high voltage side, that no current would be able to travel through there. Maybe there's a little bit. Surely there's nothing significant enough to power 2 incandescent bulbs, because resistive based lighting uses massive amounts of energy dissipated as light and heat. Yet when we turn the circuit on now and the 60 hertz is pulsing the MOT, the high voltage is pulsing these 2 hairpins, we turn it on, and what do we see? The incandescent bulb lights up. That incandescent bulb lights up. The primary isn't being pulsed right now. This would indicate DC is traveling through the circuit. Now the spark gap that we previously had closed, if you look at our voltage, this is voltage right across the hairpin, the outer hairpin of the high voltage side. We're looking at about 95 volts. Now when I start to open the spark gap and we actually get some oscillations and things start disrupting, our voltage immediately jumps way up, over 300 some volts. The incandescent bulbs get brighter. Now, Ohm's law suggests that 2 equal resistances in series would decrease the current, whereas 2 in parallel would have the current. Would have the resistance and double the current, making them brighter. However, the exact opposite is observed here. When these 2 bulbs are in parallel, they barely light. When I add them in series, to where the resistance is doubled now, plus the resistance of this coil, and whatever reactive inductive power it's adding to the circuit, the current appears to be increased. Now my spark gap isn't great. If I had this in a vacuum, I suspect that I would get much better results here. But as I open it up, and the more it opens, the more it disrupts. You know, I only have a small window to play with, but when it does disrupt, they do get extremely brighter. Now these are extremely hot as well. As you see, I can put my, well, they haven't been running very long. I had them up to about 130 volts. 130 degrees Fahrenheit for a while there. This thing has a hard time reading anything reflective like that, so I'll have to show you that another time. But I did read about 130 degrees Fahrenheit earlier. So, what next? Could these be heat lamps? Could they heat a copper heat exchange unit, and perhaps a little fan could blow some air through there and circulate heat using